Hi guys, so today we're going to use Pythagorean identities in order to solve quadratic equations. So before we jump into the equations, we want to make sure we review the Pythagorean identities. Remember, our most basic one is that sine squared theta plus cosine squared theta equals 1. If we divide everything in there by cosine squared theta, we get the second one, tan squared theta plus 1 equals secant squared theta. And if we divide everyone in the original by sine squared theta, we get the third identity, 1 plus cotan squared theta equals cosecant squared theta. However, we've also learned that a lot of times it's important for us to manipulate the identities, that they're not always going to be used in their original form. So for instance, if sine squared theta plus cosine squared theta equals 1, then we know that sine squared theta is 1 minus cosine squared theta. We also know that cosine squared theta would be 1 minus sine squared theta. And if we know that tan squared theta plus 1 is secant squared theta, then tan squared theta is secant squared theta minus 1. And if 1 plus cotangent squared theta equals cosecant squared theta, then cotangent squared theta is cosecant squared theta minus 1. So you're going to need to have these identities at your fingertips. So let's try solving an equation. So we're going to solve the following equations when x is in that domain from 0 to 2 pi. So in other words, 0 is less than equal x is less than equal 2 pi, which means we're going to have our answers in radians. And if we look at this equation, we have a cosine squared of x and we have a sine x. We have two different trig functions. That's a problem. We cannot factor, we cannot simplify, because it's not factoring with is the greatest common factor, and we can factor them out and separate them. This is a trinomial to factor. So we look at our Pythagorean identities and look for the one that has sine and cosine. Well, we have cosine squared. So cosine squared x is 1 minus sine squared x. So we're going to make that substitution. We're going to substitute, doesn't want to change it, we're going to substitute this in for cosine squared x. So that this becomes 2 times 1 minus sine squared x plus 3 sine x minus 3 equals 0. Now we're solving just like we were our regular quadratic trig equations. We're going to distribute the 2. Okay. Now let's see. We have negative 2 sine squared x's plus 3 sine x. And if we have 2 minus 3, that's minus 1. Now we don't like to factor when the squared term is negative, so you can either multiply every term by negative 1 or divide every term by negative 1, and then we would have 2 sine squared x minus 3 sine x plus 1 is still going to be equal to 0. Now we're ready to factor. This is a trinomial with a leading coefficient of 2. So we're going to say, okay, 2 times 1, first times last, is 2. We need two numbers that multiply to the positive 2 and add to this negative 3. What would they be? That would be a negative 2 and a negative 1. So we're going to break this negative 3 sine x into negative 2 sine x minus 1 sine x. Then we keep the plus 1 equals 0. Now we're going to separate this into two groups. And if we look at the first group, they have a 2 and a sine x in common. That'll leave us with a sine x minus 1. And then if you look at the last part, they have a negative 1 in common. Now if I only took out a positive 1, we wouldn't be able to factor by greatest common terms. But if I take out the negative 1, now you can see this term is the same as this term. So we have this common sine x minus 1, but that leaves us with a 2 sine x minus 1 equals 0. Okay, so we're going to come up here and we're going to set each factor either sine x minus 1 equals 0 or 2 sine x minus 1 equals 0. Well, if sine x minus 1 is 0, that means that the sine of x is 1. And if you think about your sine graph, it was 1 at 90 degrees, or pi over 2. Over here, we add the 1 and divide by 2, so sine x is positive 1/2. Now the reference angle. The sine of what angle is 1/2? That would be 30 degrees, or in radians, pi over 6. But we know that all students take calculus, so sine is positive in the first quadrant, which we like because that means the angle is the reference angle. But sine is also positive in the second quadrant. And if we're in the second quadrant with a reference angle of pi over 6, we want to know how close that is to pi, which is 6 pi over 6. We need the same denominator. 6 pi over 6 minus pi over 6 is 5 pi over 6. If you don't like doing it in radians, you would have said, okay, I am 30 degrees before 180 degrees. That's 150 degrees. Then take your 150 degrees times pi over 180 degrees. It's 150 pi over 180. 30 goes into 150 5 times, and 30 goes into 180 6 times, and now you have the same answer. So now we can say that x can be pi over 6, pi over 2, and 5 pi over 6. And here we have 3 solutions for our quadratic trig equation. Let's try the next one. Here we have 2 cosecant x minus 3 cotangent squared x. Again, I've got 2 trig functions. I've got a cosecant and a cotangent squared. Odds are the one that's squared is the one that we're going to change. So I look for a Pythagorean identity that has cosecant and cotangent. There it is. Now the one that's squared is my cotangent. So can I solve this for cotangent? I can if I subtract 1 from both sides. Notice I also changed my thetas to x's, okay? So I'm going to rewrite this equation, and it starts out the same, but now I'm going to change the cotangent squared x into cosecant squared x minus 1. And then the rest of my equation was equal to 2. Now, here we go to work. We are going to distribute the negative 3, sorry. So I'm going to have minus 3 cosecant squared x plus 3 equals 2. So that means I have negative 3 cosecant squared x plus 2 cosecant x, and if I subtract 2, I'll have plus 1. Now again, we don't like to have our squared term negative, so we're going to multiply everything by negative 1, and I'll have 3 cosecant squared x minus 2 cosecant x minus 1 equals 0. Now we're ready to factor. We have a trinomial where our leading coefficient is 3. So we're going to say, okay, 3 times negative 1 is negative 3. I need 2 numbers that multiply to negative 3 and add to negative 2. That would be negative 3 and a positive 1. So I'm going to have 3 cosecant squared x. So I'm going to rewrite this middle term as negative 3 cosecant x plus 1 cosecant x, and then we keep the minus 1 equals 0. Now if we group the first 2 terms and then group the last 2 terms, so in the first 2 they have a 3 and a cosecant x in common. That will leave us with a cosecant x minus 1 plus, now all the next part has in common is 1. That's it, nothing else. So then it's cosecant x minus 1 equals 0. Before and after the addition, we see the common term cosecant x minus 1. But when we take that out, That's going to leave us with a 3 cosecant x plus 1, and that product is still equal to 0. So now we take each factor, cosecant x minus 1 equals 0, and 3 cosecant x plus 1 equals 0. So if cosecant x minus 1 is 0, then cosecant x is 1. Now cosecant, I didn't memorize everything, but I know cosecant is the reciprocal of 1. So if cosecant x is 1, sine x is the reciprocal of 1, which is still 1. And if I think about this, sine is 1 when x is pi over 2. So here is an answer. Now on the other side, solving for my cosecant x, I subtract 1 and I divide by 3. So cosecant x is negative 1/3, which means that sine x is the reciprocal, which is negative 3. Now there's a problem with this, because sine only goes as low as negative 1 and as high as positive 1. It will never be negative 3. There is no solution there. So our only solution was x equals pi over 2. Okay, guys, that's it for now. Bye.